Number 30, we're starting on transformations and looking at them algebraically instead of graphically. So here, it says write a rule for G that represents the indicated transformation of the graph of F. So this just means we're going to call it G of X when we're done. Okay, so we're starting with e to the negative x, and it asks for a translation 2 units to the left. So to left. So I'm going to replace x with x plus 4. 2. So e to the negative x plus 2, that's 2 units to the left. Well, I now have a negative out here, so I need to distribute this negative. So this is actually e to the negative x minus 2. Okay, next thing, 3 units up. I take what I had before, just add 3. And then a vertical stretch by 2. Stretch by 2. Remember, you need to multiply the whole function. That means that 2 is going to distribute to both terms. So this becomes 2e to the negative x minus 2 plus 6, and we call that g of x. Okay. Logarithm, log base 9 of x. We want a translation 3 units to the right. That is going to be log base 9 in parentheses x minus 3. Okay, 1 unit down. Log base 9, x minus 3 minus 1. And then followed by a reflection in the x-axis. Reflection in x-axis. Okay, I'm going to put a negative in front of the whole function. Again, I have 2 terms. It's a big one, but this is 1 term. Nothing's going to get affected in here. And then I have this one. So if I put a negative in front of these 2 things, okay, this is going to get distributed. So I get negative log base 9 of x minus 3 plus 1. And that's my g of x. Okay, let's move this up. Okay, number 32. Just have a simple e to the x, vertical shrink. So shrink by 1/4. We just throw the 1/4 right in front. Followed by a translation 5 units up, 5 up. This is 1/4 e to the x. I take what I had before and add 5. And that's my g of x. Okay. Finally, with these, we have log base 1/6 of x. We have a vertical stretch by 9. So stretch by 9 is going to give me 9 times log base 1/6 of x. Followed by a translation 2 units to the right. So this is 9 times log base 1/6 x minus 2 in parentheses. And then 3 down, down 3, or I know I wrote it the other way up there. Okay, we have 9 log base 1/6 of x minus 2. That is all 1 term. Okay, I know it's a lot, but that's all 1 term. And then 3 units down. And that's going to equal my g of x. Okay, these last 3, I may not get them into this video, but The trick to these, and you will have a calculator for these, the trick to these is knowing which formula to use, okay? One has an E in it, one doesn't. So this first one says you invest $50,000. Man, wouldn't it be nice to have $50,000 to invest? In an account that is compounded continuously at 3%. How much money will you have after 15 years? Okay, so I'm looking at these two, and say I go with this one, and I go, okay, what's N? How many times a year is this compounded? Well, this says continuously. How do I write that as N? I can't. So that's how I know to use this one. This is A equals PERT is your continuous equation, a formula that you use. Okay, so A equals my original principal, $50,000, times E to the rate in decimals times 15 years. Okay, so now when I put this in my calculator, got 50,000 times E to the, I don't know if, E to the X power is right here, okay? Times E to the 0.03 times 15, and I get $78,415.61. All right, number 35. Let's see where I'm at with time. Ooh, shoot. Okay, let's finish this in the next video.